Okay, so this is a walkthrough of the first boss battle, the level 1 solar sail activity. And we're going to go through all the steps that you needed to do to get to the correct answer or a correct answer. Your answer may vary slightly. So first we have the description of the task, and what we're going to be doing is using a sample of carbon to determine the density of carbon, which is what the sail will be made of. And ultimately, we need to figure out what is the maximum area of sail that we can possibly have, given the information that we're given in the description. These are a couple of formulas we're going to need. Density equals mass over volume, and then the other two, volume equals mass over density, and mass equals density times volume, come from the same equation. We're going to start with the density of our sample. So we need the mass and the volume of our sample. We're going to take our balance, make sure it's zeroed out with nothing on it. And then when we add our sample, we get a mass of 0.99 grams. So we're going to record that on our data sheet. And now we need to find the volume. Here is a graduated cylinder filled to 8 milliliters. You can see it's right on the 8. We actually record that as 8.0 in our calculations. And we can't find the area or the volume of our sample because it's irregular by measuring it with a ruler, but we're going to use this displacement method. So we start at 8 milliliters. And then after we put the sample in, it's kind of hard to see here, but the bottom of the dark section there, that's called the meniscus. It's a little dip in the water level. We would read. So that dips out right at 8.4. So 2 lines up from 8, 8.4 milliliters. And since the initial volume was 8 and the final volume was 8.4, that means that the volume of the sample that we put in the water was 0.4, because the water is the first 8 and anything over the 8 is the sample. So 0.4 milliliters is the volume. Now we have the mass of 0.99 grams and the volume of 0.40 milliliters. Divide that out, and we get a density of 2.475 or 2.5 grams per milliliter. We round it because both of our starting numbers had 2 significant figures. So we have the volume of 0.40, the density of 2.5. Now, to find the area, we need to know the volume and the thickness, because volume is area times thickness, which means area is volume divided by thickness. So in order to do that, we have to go back to the description, which says down here at the end, the final thickness of the sail is 0.3 nanometers. Now, the data sheet asks for the volume, the thickness in centimeters. So we're going to need to convert that. And to do that, we need to look at the conversions we're given on the back of the sheet, which says that 1 nanometer is equal to 0.000000001 meter, and 1 centimeter is 0.01 meters. So we can convert nanometers to meters and then meters to centimeters, and therefore we're going from nanometers to centimeters in 2 steps. So we set it up like this. We have our 0.3 nanometers and then our conversion of meters to nanometers in the first conversion factor times centimeters to meters in the second conversion factor. We multiply all that out, and we find that 0.3 nanometers is equal to 0.0000003 centimeters. So that's 7 zeros after the decimal point. Or this could be written as 3 times 10 to the negative 8th centimeters. So now we have our mass and volume of our sample. We have the density of the sample, which is also the density of the sail, since they're made of the same material. And we know the thickness of the sail. So in order to get the area, we're going to need to know the volume. Well, we can't tell the volume directly because we don't have it, but we are given the mass and we have the density, which we've already calculated. So mass divided by density equals volume. Well, the mass is given in the description here. It says 100 kilograms is the maximum weight that we can have. And since we want the largest possible sail, we're going to go up to the limit of 100 kilograms. We need that in grams, though, so we have to convert kilograms to grams. 1 kilogram is equal to 1,000 grams, which means that 100 kilograms is 100,000 grams. 100 grams times 1,000 over 1, 100,000 grams. So we plug in our mass of 100,000 grams. That's for the sail. The sample was something different. Now we're talking about how this big sail is going to weigh 100,000 grams. The density, though, is the same for both the sample and the sail, since we're saying they're both made of pure carbon. So the density of 2.5 grams goes on the bottom, 100,000 grams on the top. We divide that out, and we find that our sail would have a volume of 40,000 milliliters. Now on the sheet, it asks for cubic centimeters, and you have to know that milliliters and cubic centimeters are the same thing. So 40,000 milliliters is equal to 40,000 cubic centimeters. So now we have the volume, we have the height or the thickness we calculated a couple minutes ago. We can use those two things to find the area, which is what we want for our final answer. So we put our volume, 40,000 cubic centimeters, on top. We put our thickness, 0.0000003 centimeters, on the bottom. We divide that out. That will give us our area, and we get a really big number, 1,333,333,333,333 square centimeters, and we would round that to 1.3 quadrillion cubic square centimeters, rather, or 1.3 times 10 to the 12th centimeters squared. And that is our final answer. We have all the data we needed. We needed to calculate the density of the sample. We used that along with the thickness and mass that we were given to find the volume, use the volume and the thickness to find the area, and we get our final answer of 1.3 times 10 to the 12th square centimeters.